Hey, welcome. This video is on the remainder and factor theorems. Let's talk about the remainder theorem first. If the polynomial f of x is divided by x minus c, then the remainder is equal to f of c. So we're talking about division, and notice that our divisor is x minus c. That means that we could use synthetic division. Okay, our last video was on synthetic division. So what we're saying then is if we evaluate f of c, we'll get the same number for the remainder as we would if we did synthetic division. Let's see, that's what this says. In other words, the remainder after performing synthetic division is the same number we would get if we replaced c into the polynomial and evaluated the polynomial. So we could get the remainder two different ways. We could either use synthetic division or we could evaluate the function at that number. So let's do that. Here's our function. F of x equals 5x cubed plus 3x squared minus 21x minus 1. So let's first find f of negative 2 by just plugging in negative 2. Everywhere you see an x, replace x with negative 2. As always, you should try to pause the video and then try to work it out on your own as you can. All right, so let's plug in f of negative 2. So that's 5 times negative 2 cubed plus 3 times negative 2 squared minus 21 times negative 2 minus 1. We need to do the exponents first, so negative 2 cubed is negative 8. Negative 2 squared is 4. So that gives us 5 times negative 8 plus 3 times positive 4 minus 21 times negative 2 minus 1. Now our multiplication, 5 times negative 8, that's negative 40. 3 times 4 is positive 12. And negative 21 times negative 2 is positive 42. Put those all in, and you should get positive 13. I would just use my calculator, right? All right, so now let's do the same problem to the right, and let's use synthetic division. So inside the box, we just put the coefficients and the last constant, 5, 3, negative 21, and negative 1. And we're going to plug in negative 2 for our divisor. So that means the divisor would have been x plus 2, since we're using c equals negative 2. All right, so let's use negative 2, work that out. Make the line, bring down the 5. Negative 2 times 5 is negative 10. 3 plus negative 10 is negative 7. Multiply negative 2 and negative 7, positive 14. Add negative 21 plus 14, negative 7. Multiply, gives you 14. And then lastly, negative 1 plus 14 would be 13. Hey, that's the same number, right? So that's all we're saying. You could either plug in the number into the equation, or you could use synthetic division. Honestly, for many reasons, I should say, the synthetic division is probably better to use most of the time. And you'll see why in a little bit. Okay, so both methods give a result of 13. Okay, here's another example. Here's our function, f of x equals 3x cubed minus 5x squared plus 3x minus 10. Let's first find f of negative 2. We're going to evaluate negative 2. We're going to replace every x with a negative 2. Very similar to the last problem. Make sure you do the exponents first, or if you're able to use a calculator, then just plug it into your calculator. Let the calculator do the work for you, right? So negative 2 cubed is negative 8, negative 2 squared is 4, and then do the multiplication. So you should get negative 60. All right, now let's do the same thing, but this time let's use the synthetic division. So we just write the coefficients and the last constant, and we're going to use negative 2 for our c. Draw the line, put the 3 underneath the line. Multiply negative 2 times 3, that's negative 6. Add the two numbers. Negative 11. Multiply again, 22. Add the two numbers. Multiply again, negative 50. Add the two numbers. Negative 60. Again, both methods give a result of negative 60. Okay, here's our next theorem, the factor theorem. A polynomial f of x has a factor x minus c if and only if f of c equals 0. In other words, if the remainder after performing synthetic division is 0, or the result from evaluating the polynomial at c is 0, then x minus c is a factor. So you could use either method. You could either use the synthetic division or evaluate f of c, and if you get a remainder of 0, then that means this factor is a factor of the polynomial, that it is a factor. This divisor is a factor of the polynomial. Okay, so here's our first problem. Is x minus 3 a factor of 3x cubed minus 14x squared plus 17x minus 6? So we want to see if x minus 3 is a factor. What we're working towards is this polynomial, 3x cubed minus 14x squared plus 17x minus 6. We're going to try to factor this polynomial. That's what our goal is. All right, so we can use either method. You could either just plug in 3. Our c would be 3, right? If it's x minus 3, then c is positive 3. So in this example, what we'll do first is we'll find f of c directly, just to show the different methods. So we're going to use c equals 3, and just plug in 3 everywhere you see an x, and then work it out. 3 cubed is 27, 3 squared is 9. Then do your multiplication. 81 minus 126 plus 51 minus 6. And that should give you 0. So yes, look at the question. It says, is x minus 3 a factor? The answer to an is question is yes or no. It either is or it isn't. Because we got a remainder of 0, it is. If we would have got an answer of 17, then the answer would be no. So that's our answer. Yes, it is a factor. All right, here's another one. Let's use the synthetic division method this time. And I'll show you why. After we do the synthetic division, then we'll see why it's a little bit better to use. Again, we're going to use our value of c. Since the divisor is x plus 3, we always use the opposite of that number. So we're going to use negative 3. Okay. So we write down our numbers inside the division box. of our dividend, 1, -4, -9, 36. And our value in C is going to be -3. Okay, work it out. Draw your line, put the 1 underneath. You always bring down the first number. Then multiply. -3 times 1 is -3. Add. That's -7. Multiply again. 21. Add. +12. The signs are different, so we got to subtract. Keep the sign of the larger number. Multiply one more time. And we get a remainder of 0. So the answer is yes, because we got a remainder of 0. Again, when you're doing homework, if you don't get a remainder of 0, if you get a remainder of 13, then the answer is no. Now, our answer that we have, that last row, 1, -7, 12, that's our new quotient, right? We also call it a depressed polynomial. Sounds like a weird phrase, right? Depressed. Because it's brought down by 1 degree. We'll get to that a little bit later. Anyways, if you write that answer in polynomial form, it would be x squared minus 7x plus 12. And we would be able to factor that trinomial. So hopefully you're starting to see why it's kind of better to use synthetic division than evaluating, because we actually get something that we can work with. The other method, we just get a number, and there's nothing else you can do with it. Okay, so now we're going to talk about factoring a polynomial given a factor. So given that we have a factor x minus c, we're going to factor this polynomial. So step 1 is we're going to use synthetic division to show that it is a factor by showing the remainder is 0. So don't evaluate it by just plugging in c. Use the synthetic division. Then our quotient that we have, we're going to write that with variables. We're going to write that in variable form. And then if possible, we're going to factor that by whatever method you like. I tend to use grouping, but whatever method you like. Then we're going to show the polynomial completely factored by bringing down that factor that we started with, x minus c, multiplied by our answer that we obtained, the quotient that's factored. All right, I know that seems confusing. Math is always that way. It seems confusing. We have to do some examples, so let's do that. Okay, here's our polynomial. F of x equals x to the third minus 6x squared minus 13x plus 42. What we want to do is we want to give the complete factorization of that polynomial. And they're telling us already that here's a factor, x minus 2. So this one doesn't say is g of x a factor, it says show g of x is a factor. That means that the remainder must come out to be 0. If it doesn't come out to be 0, and I say show, or your teacher says show it's a factor, then only two things happen. Either the teacher made a mistake or you made a mistake. Okay, so double check your work. So when they say show, it means it has to come out to have a remainder with 0. Let's do it. Let's do our division. So we write down our coefficients and our constant, 1, -6, -13, 42. And our divisor is x minus 2, so we're going to use positive 2 for c. Okay, go ahead and do the work. Bring down the 1, multiply, -4, multiply, negative 21, multiply, negative 42. There it is. We have to get a remainder of 0 because it says that show g of x is a factor. Next step. So there's our quotient. We're going to write it in proper form. That means variable form. It started out as x to the third in the original polynomial. So we decrease the exponent by 1. So then the 1 will be the coefficient of the variable with a degree less by 1 from the original polynomial. So it's going to be x squared. And then each one decreases by 1 following. So x squared minus 4x minus 21. So now can we factor that? Yeah, we could factor that. Let's see, 21 is only 3 times 7, and 1 times 21. We want to find the pair that subtracts to be 4. Right, 3 and 7. Negative 7, positive 3. If you want to just put it in, you can. If you want to show it by grouping, you can. Totally up to you. Factor out an x. I'm showing by grouping. Factor out an x from the first pair. That's x plus 3. Factor out a negative 7 from the second pair. X plus 3. So we get x minus 7 times x plus 3. Okay, so now we want to show our complete factorization, the whole answer. So the whole answer is not x minus 7x plus 3. That's part of the answer. The whole answer, we have to show the original factor that they gave us, the x minus 2. So don't forget to write these two new factors along with the original one that they gave us. So that is f of x completely factored. X minus 2 times x minus 7 times x plus 3. Okay, here's another one. Very similar to the last problem, same thing. Show g of x is a factor. That means we have to get 0 for a remainder. All right, let's do it. All right, so negative 2, I just went ahead and put it all there. Hope you don't mind. Pause the video, make sure it works out. So 6, 5, negative 12, and 4. And then because it's x plus 2, we're using negative 2 as our divisor. Negative 2 is the value of c, and we do get a remainder of 0. So now we're going to write that in polynomial form. The quotient, 6x squared. We always decrease by 1 from the original polynomial, and then each term gets decreased by 1. So 6x squared minus 7x plus 2. Okay, now a little bit of factoring. Multiply the first number and the last number. That's 12. 1 and 12. Again, you might have another method. You might use a diamond method or an X, some kind of box, all kinds of methods. Let's see, which pair will add to be 7? Right, the 3 and 4. And it has to be a negative 7, so both negatives. It doesn't matter which order you put the 4 and 3. All right, 3x from the first pair gives you 2x minus 1, and a negative 2 from the second pair. So that factors to 2x minus 1 times 3x minus 2. Order does not matter. If you have the 3x minus 2 first, that's fine. All right, is that our answer? No, right? You got to bring down that x plus 2. So that's our final answer. All right, let's do one last problem here. Let's go ahead and do the synthetic division. Okay, now be careful with this one. Notice that it's skipping some terms, or some terms are missing. It goes x to the 5th, then x to the 4th, and there is no x cubed, so you have to put a 0. There's no x squared, another 0. And then the 16x, so then you put the minus 16, and then the last term is minus 16. And our c is -1, so you go ahead and do your synthetic division, and we do get a remainder of 0. Again, try to pause the video, work that out for yourself, make sure it's all copacetic. All right. So now it's x to the 4th minus 16. I wanted to do this example because maybe it's been a while since you've done some factoring. This is actually the difference of two squares. The first term is a perfect square and the last term is a perfect square, and there's a minus in the middle. So this is called the difference of two squares. Okay. I have videos, or you can find videos on anything, right? But this is called the difference of two squares if you want to do a little bit of review. So this factors to x squared minus 4 times x squared plus 4. Then the x squared minus 4, that again is the difference of two squares. That will factor to x plus 2, x minus 2. But the x squared plus 4 does not factor any further because there is no formula for the sum of two squares. Okay, and then don't forget to bring down the x plus 1 for your answer. And that's our final answer. Okay, that was it for this video. I'll see you here for the next one. Have a good day.